Good day, everyone. My name is Zikri Berosli. I'm a manager here. First of all, thank you for joining me today. I'd like to address a critical issue concerning thermal stress on our railway tracks. Thermal expansion pose a substantial risk to the integrity of the railway system. It is imperative that we tackle this problem and find solution to mitigate the associated risk. So, Ko, I am interested in hearing your opinion on this matter.
So let me address the issue. So first of all have to know that this is the picture of the railway track. So there is the left four picture is the different view of the railway, and the right side is the failure in railway track due to thermal stress. So just like our manager Zikri addressed just now, thermal stress is the one of the primary factor that lead to the railway track failure. So when a railway track is exposed to temperature variation, maybe it's too hot or too cold, the track material could be expand or contract, so leading to change in length. So this change can cause internal force and stress within the track structure, leading to deformation and buckling or failure if not adequate managed. So to know this thermal stress, the theory of it, we have to know of the expansion theory, which is the deflection equals to alpha E delta T. So which is alpha will be the material linear coefficient of linear expansion. Delta T will be the change in temperature, and E will be the modulus of elasticity. So this is and when the heat is too high, whether we suspect that the weather maybe is too hot, so the gap that we reserve for it maybe is not enough for the track, so it caused this railway track happen, I suspect.
Okay, thanks, Ko. So, can I hear I'm from another engineer?
Yeah, my name is Karthik Varman. So I'm engineer number 2. So I'll be explaining about the modification, which is the continuous welded rails, CWR. Right? So next slide, please. Okay. So for this continuous welded rail CWR, to keep it short and simple, so we can categorize it into benefits and disadvantages. So for the benefits, these continuous welded rails, like not compared to the traditional rails, will be joined together. It will form a straight line for miles. So what will happen if you make it as a straight line? First thing, it has high strength because we have joined it, we have made it all together. Instead of being an individual member and the individual member cannot sustain that much weight and pressure and also friction. If you make it as a long member, it can distribute the load and the friction throughout the member. So that's why it's high strength, smooth traveling. If there's members that have bump along the train as the transaction from one member to another member, so smooth traveling can be achieved by joining all the members and forming a straight line for miles. So less maintenance. As once you form it as straight line, so there won't be that much of corrosion, damage, and thermal stress occur. So there's no need to be that much of maintenance and reinstalling back the railway track. So for the disadvantages, as you want to form the long member installation process, it's really it's really complicated, and also the labor force required for that is really long. It takes months or years, even years. So that's it for the benefit and disadvantages. So another thing I wanted to add is they might contain joints. That's just like small joints, such as insulated joints that electrically divided segments for signaling needs. So this is the only joint. These are one of the example of the joints which will be formed within the miles of the member, just for the function of electrically divided segments for signaling needs. So that's it for me. Thank you. So I'll pass it on to engineer number 3.
Hi, my name is Dinesh Ravi. As an engineer, I'd like to suggest a modification to the railway tracks, which is a railway stress monitor. As we know, Malaysia is a tropical country, which the weather is cannot be predicted. It can be hot or cold, and the changes in weather can contribute to the thermal stress, which ultimately contributing to the thermal expansion. So the most effective way to record the thermal stress, which at the railway tracks, are using a device called railway stress monitors. We can't place a person to stand there and monitor the stress the whole day. It's impossible, and if it does means it will may have a lot of human errors. So this device can always continuously can measure stress in the railway tracks and can send the information to the operators to perform any maintenance if needed, and also to prevent any accidents, such as if the stress is too high and deformation is too high, it can cause a bump inside the railway tracks, which can cause the train slip. And final and most important benefit of using thermal stress monitor is it will give alert or alarm if there is a issue with the integrity of rail. So if there's a crack or anything with the train track, it will give a alarm or warning to the operating center to carry out the necessary actions. So I think this is a very important and crucial modification to the railway tracks for our company. That's it from me. Thank you.
Excellent. I appreciate the dedication and expertise each of you bring to this project. Let's continue working collaboratively to finalize the modification plans and the implementation of the rail stress and monitoring system. Once we have everything in place, we can move forward with the necessary approval and ensure a smooth transition. All right, that's all. Thank you.